Let's start taking a look at Numpy Package. So Numpy Package is usually used to handle arrays and vectors and matrices very efficiently. And Numpy also provides certain functions that are very efficient and also very useful to us. So to demonstrate that, I will start with the np for NumPy, a range. So this function has a very similar behavior to the native Python function called range, but it's usually more efficient and allows for more options. So for instance, I can create a range of values from 0 to with the length of 10, and that is from 0 to 9. Typically, we sometimes specify, for instance, the starting number and the ending number, and this will just create a list. Of course, the behavior is the same here. We'll never have the 11 in it. It stops 1 before that value. So that's how we use a range to create an array of indices. We can also specify other arguments on that function. So for instance, if I want to start from 20 and go up to 120 with increments of 10, we can specify the increments. And as with the case before, the 120 is not included, so we expect it to stop just before that. So let's take a look at the result of this function. It starts at 20 and then it adds steps of 10, so 30, 40, and it stops just before it reaches 120. So the last one, 120, is omitted from the final result. As you can see here, this is an array. This is not a list. So if I print the type of indexes, I can see that it is a NumPy ND array. So that's a NumPy object that stores arrays, and it's very, very efficient. With this NumPy array being its unique object in Python, it comes with some methods that are useful to us. In order to demonstrate these methods, we're gonna take a look at some of them. So I will start with this reshape method. So indexes equals indexes dot re, and then I can press tab and it will show the options, and I'm looking for a reshape. So reshape allows me to transform this 1D vector into a 2D vector or more dimensionalities. In this case, it's just gonna change it to be 2D, and it's gonna be a 5 rows by 2 column array. So let's take a look at the output of this function. So I had a 1D array before, and I'm reshaping that array to be 5 by 2. So each row is gonna contain the pairs of 2 numbers in this final array object. Just like with lists, we can also slice NumPy arrays. So if, for instance, if I want to slice up to the second number, up to the second row, I can slice it. But because we now have a multi-dimensional array, we can do multi-dimensional slicing. So for instance, if I want to grab the first column of this index array, we'll just need to specify column. That means I'm grabbing all the values from this dimension, and I'm just slicing the first index of the second dimension. So this gives me the entire first column. If I want to slice the second column, I can change the index of the column to 1. So that's how you would slice by column. We can also slice by the rows. So in that case, I need to specify the index of the row and indicate that I'm slicing all the columns of that row. So this should give me 20 and 30. So that's 20 and 30. Similarly to the lists, we can also use negative indexes to slice the last values or last indexes of the array. So this should give me the last row of this array, which is 100 and 110. And that's what I get. And finally, we can also access individual indexes within this array just by providing the indexes, the two-dimensional indexes in this case. So the first item is index 0 for the row and index 0 for the column. So that gives me 20. If I want to access 50, I would have index 1 here and index 1 here. And I can also access individual indexes by using negative indexes. That's just gonna access the last value there. We can also provide lists of indexes in order to slice a array. So let's say I want index 1 and index 3 for the rows, and I want to slice all the columns. So this will take the row 1 and 3, so that's row 1 and 3, and slice for 1 would be that one, and 3 this one, and slice for all the columns. So you can provide indices as a list of integer as well. There are other ways of slicing NumPy arrays. One of these ways is to define a keyout. So if I say my keyout is indexes, and then apply a boolean operation, which is looking for the first column of my array. I'm looking for all the numbers that are greater than 50. And then if I look at the result, we have two numbers that are not greater than 50 and everything else is greater than 50. And therefore we get 2 falses and 3 trues. The result of this boolean operation is also a NumPy array. And with that, we have access to all the methods that we would with a NumPy array. So one of the things that we can do with a NumPy array, even indexes or a array or a vector like this, we can do a .sum. So .sum in this case is just gonna make the summation of all the elements within this keyout. Keyout is a boolean array, and every time we make a summation on a boolean array, the value of false is going to be 0, and the value of true is going to be 1. And therefore, when we make the summation, we are actually calculating the sum of every location that is true. So we have 3 locations that is true. So now let's use that keyout to slice our array. So we have our array of indexes, and we want to slice the rows where the keyout is true. So we want to grab all these rows. So in order to do that, we can say sliced equals and then indexes and keyout. So when I do this, what NumPy is going to do, it's going to find out that keyout matches the length of the rows, and it's going to use this keyout to select the rows where the keyout is true. So if I run this cell, sliced gives me the last 3 rows where this condition is true. If we want to invert the boolean array so that every place that is true becomes false and every place that is false becomes true, what we can use is to use the tilde operator. So if I run this, what it does, all the locations where it was previously false is now true, and the locations where it was previously true is now false. And then if I now slice my array with that, I get the other rows. I get the initial 2 rows where it's now true. There are many methods available for NumPy arrays. We have seen the reshape, we have seen the sum, and there are others. I will demonstrate one more, but as you look into our instructions and all the videos that we make and the workflows, you will see NumPy functions and NumPy arrays pop up everywhere, and we use methods from those objects very often. So the one I'm demonstrating here is going to be the mean. So another function that's available for NumPy arrays is the calculation of the mean. So if I just run mean on my original array, it's gonna calculate the mean of all values within my indexes. So this is the average value of everything that's contained here. But I may want to calculate the average value given a given dimension. So for instance, if I do indexes mean, and the argument here is the axis, and if I say axis is equals to 0, it's going to calculate the mean of each column of my array. So in this case, it returns 60, which is the average of the first column, and 70, which is the average of the second column. If I want to calculate average by row, I can do indexes.mean and use the axis equals 1. So that is going to give me the average of each row of my array.